Bones, the very support structure upon which our bodies are built. Any problems in this structure and normal life comes to a grinding halt. The human body does have an internal mechanism to heal its own bones, but sometimes this process needs a bit of a helping hand. Problems like fractures, the decay of bone, and cancerous tumors can be especially tricky to deal with. While it's not impossible to treat these forms of bone loss, it can be difficult. Conventional treatments for these conditions can be metal plates drilled into healthy bone, synthetic bone grafts, or even grafts taken from elsewhere in the body. All of these methods can be expensive, with an added risk of infection, rejection by the immune system, or even a second surgery. People who are unable to afford such procedures end up foregoing the treatment, leading to a lower quality of life and further bone loss.
After about a decade of research work, we have come up with a solution that removes our dependency on traditional bone implants and bone grafts. Moreover, it reduces the risk associated at a fraction of the original cost. We call this a 3D bone graft, and it is used to fill the space between two bones, a bone joint or a bone void, where it promotes the neighboring bone to lay down new bone, new minerals, and thereby helps the body heal itself. And in the process, this material, the 3D bone graft, gets eaten up or resorbed by the body, thereby avoiding the need for any revision surgeries subsequently.
After a long and arduous process, 3D bone graft has been approved for human trials on jawbone-related indications by the Drug Controller General of India. We are now looking for clinical experts and orthosurgeons who will use the product and provide their feedback on the product's performance.
The material as well as the process of manufacture has been patented and can be tweaked so as to produce either a strong 3D scaffold or a flexible spongy mass. By molding or by 3D printing, it is possible to customize this to either standard shapes or to custom shapes which we can derive from CT scans, which will allow us to handle defects which are complex in nature and large in size. Thereby, we are in a position to help surgeons and patients heal themselves with respect to bone defects.
Also in the works are applications for trials in other indications, making the product viable for use across the body. The ultimate aim is to give patients and surgeons a low-cost, natural, and safe solution to what can be a life-changing event, allowing the patients to walk with a spring in their step and their heads held high. The history of jaggery in India, also called gur in Hindi, is centuries old. But it lost much of its market to the cheaper and sweeter alternative sugar in the mid-1800s. In recent years, however, jaggery has been making a resurgence as a healthier and more organic option to sugar, mainly due to the fact that not much innovation has been brought to the traditional methods. Production usually takes place in small rural units operated by farmers. The process is labor-intensive, requires skill, and is only viable for some months of the year. Due to this, producing good quality product becomes a costly affair, considering the small scale at which the farmers operate. No surprise then that a survey conducted in the region of Kolhapur found that more than 50% of rural jaggery units had shut down in a short period of more than 3 to 4 years.
So we saw the problems of jaggery making in the way it is manufactured at present, and have come up with a new production process which is hygienic. That means there is minimal human touch. The process is highly automated. Then the product that is made is of consistent quality because it's a continuous process. And it is economical because the cost of labor would go down per ton of jaggery made. Okay, so if it is operated at a particular scale, it can definitely go with the same price or even lower price. Production process is continuous in nature, and we can deploy it depending on the requirement in various modes.
First is a fully functional but fixed plant able to produce up to 10 tons per day. Second is a model where farmers can use our technology to update their rural setups, reaping the benefits of better quality and consistency. The third model, and the one we're most proud of, is a mobile jaggery production plant. Built on a tractor-tray combo, it can be taken directly to the sugarcane fields to produce quality jaggery right there, thus eliminating transport costs for the sugarcane. Imagine having the production plant come to the raw material instead of the other way around.
So far, we have operated it for more than 2 or 3 years, and we have collected enough data and gathered enough confidence to make us ready for further step of scaling up at a commercial level. Our aim or our objective is to bring the health benefits of jaggery to the world in a cleaner, more sustainable, and in a socially responsible way, while still it would be commercially viable.
Agriculture, with its allied sectors, is unquestionably the largest livelihood provider in India, more so in the vast rural areas. It also contributes significantly to the national gross domestic product. Indian agriculture and allied activities have witnessed a green revolution. Here are some of the traditional methods practiced by the farmers. The seeds are gathered at one place and allowed to dry in the sun. Another method involves using ash as a preservative to treat grains such as grain sorghum, pearl millet, cowpeas, mung beans, and groundnut. Here, some plant fibers are kept over the mung beans and ash mixture and sealed with cow dung. Earthen pots made of clay are also used to store seeds. Walls of the pots are coated with clay and the mouth of the pots are closed with plant fibers and stiff cow dung. An alternative method preserves air potatoes and melon, pumpkin and bottle gourd fruit variety seeds in baskets. These baskets are left to hang from the ceiling for about 10 months. Grains such as cowpeas, mung beans and pod seeds can also be stored this way. Seed storage is an important process in maintaining the viability and vigor of the seeds during the storage period. The high moisture content only encourages fungal and insect problems. The inadequate storage conditions can further lead to the loss of seed quality. Let us now hear about the key issues of storing seeds and the expectations from the farmers in the Jawahar region of Maharashtra.
आम्ही ते हे भात आम्ही झोडतो आणि मग नंतर ताटकामध्ये ठेवतो आणि बियाणं एक वर्ष राहतं त्याचे दुसऱ्या वर्षाला राहत नाही मग ते त्या अडचणी आहेत त्या कशा ठेवायच्या कशा पद्धतीने
जूनमध्ये जी बियाणं जर घेतलं ना ते जूनमध्येच पेरणी करायची दुसऱ्या वर्षात ते चांगलं राहत नाही खराब होऊन जातं किडा वगैरे लागतात
कणगीत ठेवत होते एक वर्षाच्या आतच वापरतो मग नाही उगत
एकूच सालात जर उंगत मग दुसऱ्या सालात उंगत नाही मग त्याला पोकळ हातात कीड लागतात.
तुमच्या यांच्यानी काय भेटलं असतात तर आम्हाला ठेवायची सोय.
तर आम्हाला अशी अपेक्षा आहे तुमच्याकडनं काहीतरी मशीन वगैरे किंवा काय असेल म्हणजे जवळजवळ 3 वर्ष तरी आम्हाला टिकलं पाहिजे ते असं बियाणं अशासाठी आम्हाला काहीतरी तुमच्याकडे काय उपाय असेल त्यासाठी तर बरं होईल.
The associated NGO group in this data center project is Bharatiya Agro Industries Foundation, popularly known as BIF. It is engaged in seed conservation efforts in the Jawahar region of Maharashtra. BIF stores seeds for the community-based farmers through seed banks to help them in seed preservation. BIF has now suggested better solutions to be developed for individual farmers. This is how Tata Centre's seed storage units have identified a substantial need.
Because of unpredictable rainfall situations, there is a need to revive this diversity for food and nutritional security, and this program should be community-led program for conservation and revival of diversity.
A seed storage unit of 200 liters capacity has been designed, developed and tested in the Tata Centre's food lab as a part of the MTech research project by a Tata fellow. This unit is expected to provide a constant temperature of 15 degrees Celsius and also ensures a lower relative humidity below 40% inside the seed storage unit. These are suggested storage conditions for medium-term seed storage. The efficacy in storing the seeds for 10 months duration is shown in the graph that outlines the benefit of using the suggested temperature and humidity conditions inside the seed storage units vis-a-vis the existing external conditions of seed storage. Germination count before and after storage is an important parameter that indicates the performance before planning a wider dissemination of the technology developed. The germination test is to assess the seed quality or viability and to predict performance of the seed and seedlings in the field. Tata Centre tried a germination test to check the germination count before sowing the seeds. A pilot activity has been undertaken to test the units at 15 different agroclimatic conditions across the state of Maharashtra. The IIT Bombay team expects to make a larger impact in providing a seed storage system at the decentralized level.